All right, in this video we're going to look at some application problems that involve radicals and just work through a few of them to give you a general flavor of ways that we can apply some of the things that we've done with radicals. First problem, the square shown below has an area of 15x. What's the value of x? And then we see from our diagram that the side length of the square is 6 times the square root of 5. That tells us that the other side of the square is also 6 times the square root of 5, since all the sides of squares are equal. Now, what do we know about the area of a square? Well, we know that the area of a square is equal to the length of the side squared, or length of the side times length of side. And so we can use that information along with what's given to write ourselves an equation that we can fairly easily solve in order to find the value of x here. First off, we're told that the area is 15x, so I'm going to put 15x in there for the area, and that's equal to the length of one side times the length of the other side. Well, they're both 6 times the square root of 5, so we can go ahead and put 6 times the square root of 5 in for both of those. Now, something that you should do here, even if you only do it mentally, if you don't actually do it this way on paper, is you should reorganize these things that we're multiplying on the right-hand side so that we're multiplying the numbers and we're multiplying the radicals. And computationally, it's the easiest way to think about it. So we'll go ahead and do that. And now I'm going to multiply 6 times 6, gives me 36. And square root of 5 times square root of 5. And well, what does the square root of 5 times the square root of 5 give me? If you think about what the square root means, the answer to this should be relatively obvious. The square root of 5 is a number that when we multiply it times itself, we get 5. And that's exactly what we're doing here. We're taking the square root of 5 and multiplying it by itself. And so the result of that computation should be 5. And now we're going to go ahead and multiply out the right-hand side. 36 times 5 gives us 180. And we'll divide both sides by 15 to get the value of x. And so x equals 12 in this problem. All right. The second example here asks us, for which of the following values of x could you further simplify the square root of 15x? Now, in order to further simplify the square root of 15x, that means that we need to have a pair of factors that we can take out of the radical in order to simplify it. So if we think about this, 15 is 3 times 5. So this is the square root of 3 times 5 times x. So if I put any of these values in here and have a factor that shows up multiple times, then that means that's going to be a value of x for which I could further simplify this radical expression. So let's try out 2. If I put 2 in here for x, 2, 3 times 5 times 2, I don't have any factor pairs. So this one does not work. If I put 4 in there, well, remember that 4 is 2 times 2. So I do have a factor pair, and I would be able to simplify further if I put 4 in there. All right, let's check out part C. If I put 5 into here for x, 3 times 5 times 5, again, I have a pair of like factors. So this one I could further simplify. And let's try out the last one, put a 7 in there for x. I don't have any matching factor pairs, so that one doesn't work. So in this problem, there are 2 values of x for which I could further simplify it, and they are 4 and 5. Okay. Do another square problem. The square below has an area of 10x. What's the value of x? Again, we go back to area equals side times side. So 10x is equal to the length of the side times the length of the side. And we'll reorganize. Multiply our numbers together, multiply our radicals together. Then take 25 times 12, which if we do that, we're going to end up with 300. And then divide both sides by 10. So x equals 30. A little bit quicker that time than the first one. Okay, and the last problem here. For which of the following values of x could you further simplify square root of 21x? And so we've got square root of 21x. If we break down the 21, this is now 3 times 7 times x. And now again, we're going to inspect and see what happens when we put these different values of x in and see if it is possible to simplify based off of those. We don't have any matching prime factors when we put 2 in for x, so that one doesn't work. If I put 4 in, remember 4 is 2 times 2, so I do have a pair of factors. If I put 6 in there, 6 is 2 times 3, so there I've got a pair of 3's, so that can be further reduced. And 8 is 2 times 2 times 2. So again, I have another pair. So there's actually 3 of the 4 answers here work in this case. Some nifty problems here. Really getting it at the depth of our understanding of how to manipulate radicals. But the whole idea that anytime we have a pair of factors underneath the radical, this is a radical that we can simplify, comes up over and over again in this kind of problem. Okay, that's the end of the video on radical applications.